videos we discussed the definition of the matrix, we discussed, and the types of the matrices we are discussing. In that, the 6 points, I mean the 5 points we discussed. In today's class, I am going to discuss what is meant by identity, or you can also call it as a unit matrix. Clear? So my dear students, square matrix, please remember it should be a square matrix in which aij elements should be equals to 0, and for all I should not equals to j. I should not equals to j. Aij means these elements are nothing but non-diagonal elements. Clear? So non-diagonal element should be 0 and aii is equals to 1. Aii means what? Aii means the subscript there, whatever I wrote, that should be same. Row and column should be same. For example, A11, A1, A22, A33, A44. All those diagonal elements should be 1 and remaining all elements should be 0. Such type of a matrix, square matrix, we can call it as a identity matrix. Clear? So if you want, you can take example. Here it is, A is equals to 1 0 0 0 1 0 0 0 1. So this is a square matrix of order 3 cross 3 where all the diagonal elements are 1, is it? So therefore this is example for the identity matrix, or you can call it as a unit matrix. Clear? And the next step I am going to discuss what is meant by null matrix. So null means what? Empty. Clear? So null matrix means you can also, this null matrix can also be called that as zero matrix. So what is null matrix, my dear friends? The name itself indicates that a matrix in which all the elements should be 0. There is no matter of diagonal, non-diagonal, nothing. Simply if all the entries or elements of the matrix is 0, then that we can call it as a null matrix. So here it is, that's why I wrote here it is all aij should be equals to 0. Clear? So example you can take, I'll take one example. Here it is example for the 0 matrix. Clear? So here it is 0 0 0 0 0 0 0 0 0. So this is a matrix of the order 3 cross 3. Clear? So this is matrix, here it is null matrix. So my dear students, it is of the order 3 cross 3. So therefore I will write it as notation, I will write it as I subscript 3. I subscript 3 means, here it is, sorry, not I subscript 3. This is will denote, I will denote for the identity matrix. So this is just a 0 matrix, my dear students. Clear? So all the elements of the matrix should be 0. Clear? So this is the example for the null matrix. So my dear students, here remember one point I forgot to tell you, that is identity matrix. So this is a matrix of order 3. So therefore 3 cross 3. So therefore we can denote it as I3. I3 means what? This is identity matrix of the order 3 cross 3. I2 means identity matrix of the order 2 cross 2. You can take example, here it is, I'll take here it is I2 identity matrix 1 0 0 1. So this is a identity matrix of order 2. Therefore I write I subscript 2. This is of the order 2 cross 2, my dear students. Clear? And next type we are going to move, that is upper triangular matrix. So what is mean by upper triangular matrix? Upper triangular matrix means, my dear students, upper triangular matrix means it is nothing but, here it is, all the elements below the diagonal element should be 0. If all the below the diagonal elements should be 0, then such a matrix we can call it as a, here it is, upper triangular matrix. Clear? So that I'll discuss. So some technical issues are there. I'll be back within a minute. Yes, my dear students, as I told, there is some technical problem is there. Yes, we'll move the next that already we discussed, that is upper triangular matrix. So what is mean by upper triangular matrix? To understand what is mean by upper triangular matrix, first of all I'll write one example, a matrix of the order 3 cross 3 I'll write, so that easily you can understand. So I'll consider, my dear students, here it is, I'll consider one matrix of the order A 3 cross 3, and we know that In the 3 cross 3 matrix, in general the elements will be like this: A11, A12, A13, A21, A22, A23, and next A31, A32, A33. So this is a matrix of the order 3 cross 3. So A11 means what it indicates? A11 means it is nothing but here it is the diagonal element A22, A33. These all elements are diagonal elements. And A11 means what? A11 means this is the element of the first row and first column element. Like this we will write. A12 means what? A12 means this is the element which lies in the first row and the second column. Clear? So like this we will write. And A11, A22, A33 we can call it as a diagonal elements. Clear? So my concept is now to understand is what is mean by upper triangular matrix. So what is upper triangular matrix? Upper triangular matrix means here it is in a square matrix. This is very very important. A square matrix A is equals to Aij, where Aij equals to 0 for all I is less than j. Sorry my dear students, make this correction. This should be I greater than j. These Aij elements should be equals to 0. Which condition? For all I must be greater than j. I must be greater than j means which elements? I greater than j means that is nothing but diagonal, the elements which lies below the diagonal. Below the diagonal means what? See here it is. You can observe. A21 means here this value is greater than this one. 31 means 3 is greater than 1. A32 means 3 is greater than 2. It means in these all cases, whatever we have here, the elements satisfies this condition. Is it? I is greater than j. So therefore, in short, we can write Aij should be equals to 0 for all I greater than j. I greater than j means it is nothing but the elements which are below the diagonal elements. Diagonal, here it is below the diagonal, principal diagonal. Clear? So if all these values are equal to 0, then such a matrix we can call it as upper triangular matrix. So we can consider the example for the upper triangular matrix. Here only I will write the example for this upper triangular matrix is nothing but here it is we can take 1 2 3, here it is 3 4 0 0 7. So this is example for the upper triangular matrix. Why it is upper triangular matrix? Because all the elements below the principal diagonal elements are 0. So therefore this is an example for the upper triangular matrix. Clear? And we will move to the next concept, that is nothing but lower triangular matrix. So what is mean by lower triangular matrix? Just opposite to this one, upper triangular matrix. So what is that one? A square matrix A is equals to Aij, where diagonal elements Aij equals to 0 for all I greater than j. I greater than j means what, my dear students? That is nothing but the elements above the diagonal. So above the principal diagonal. You can observe here it is I is greater than j. Here it is I is lesser than j, or else I is lesser than j, I is lesser than j, 1 is less than 2, 1 is less than 3, 2 is less than 3. So therefore all these elements are Aij equals to 0 for all I less than j. So it means the elements above the principal diagonal should be equals to 0. Such a square matrix, always remember this one, we are talking all this under the square matrix. Clear? So a square matrix is said to be lower triangular matrix if all the elements above the principal diagonal is 0, then such a square matrix we can call it as a lower triangular matrix. So example again, for this I can write it as, my dear students, take the example as any matrix, square matrix I am taking. So here you can take 3 4 5, and here it is 0 0 0 7 8 9. So this is a lower triangular matrix because all the elements above the principal diagonal elements are 0. These all elements are 0. So therefore this is a example for the lower triangular matrix. I hope you understood, is it? So next we'll move to the next concept, that is equality of matrices. So when we say that two matrices are equal, so to say that two matrices are equal, my dear students, observe here, it is equivalent is different and equality is different. So first I'll discuss what is equality of the matrices. So equality of the matrices means, see it is the symbol for the equal, two matrices are equal or equality of the matrix, the symbol is nothing but A is equals to B. And when we say that if we have the matrix A is equals to Aij of the order m cross n and another matrix B is equals to Bij of the order r cross s, then if m is equals to r, m is equals to r means the number of rows in this matrix and the number of rows in this matrix should be same, and n is equals to r, n is equals to r means what? The number of columns in this matrix, the number of columns in this matrix and the number of columns in this matrix must be same. It means both should be of the order, here it is same order. Is it nothing but same order? The number of rows should be same and the number of columns should be same. It means the two matrices whose, here it is, which should be of the same order, and the second condition is Aij is equals to Bij. Aij means the elements in this matrix, Bij means the elements in this matrix. Corresponding elements should be same. That is nothing but two matrices are said to be equal if the order should be same and the corresponding element should be same. Then such a two matrices we can call it as equality of the matrices, or equal matrices we can call, and the symbol for this is equals to. Understood? So I can take the example, here it is, if you want, means A is equals to 1 2 3 4. This is a matrix of the order 2 cross 2 and another one matrix 1 2 3 4. This is also matrix of the order 2 cross 2. Here A is equals to B because both are of the same order and the corresponding elements are also same. So therefore these two matrices are equal. Equality of these two matrices we can call. Clear? Similarly, we can take the next one, equivalent matrices. So in equivalent matrices, the symbol is this much. So equivalent means what? Equivalent means this, again the if two matrices, if A is equals to Aij of the order m cross n and another one matrix B is of the order, here it is r cross s. These two matrices are said to be equivalent if m is equals to r and n is equals to s. It means the order should be same, that's all. If the order is same, that's it. You can say that equivalent matrices. There is no matter of the corresponding elements. Elements may be different, but the order should be same. Such a two matrix, we can call it as such a two matrices. We can call it as equivalent matrices. Again, if you want, you can take the example, my dear students. Let us take A is equals to 1 2 3 4 and another one matrix B is equals to 7 8 9 10. So these two are equivalent matrices but not equal matrices. Equivalent means what? Equivalent means here, what is the order of this matrix? 2 cross 2. What is the order of this matrix? 2 cross 2. Here the number of rows in this matrix and the number of rows in this matrix are same. The number of columns in this matrix is 2. The number of columns in this matrix is 2. Both are equal. Therefore, these two matrices are equivalent but not equal. To say equal, the elements must also be same. Then we can say that equivalent, that we can call. Clear? My dear students, this is all we know, but in sometimes what happens in examinations, we will get confused what is equivalent and equality. So therefore this synopsis is very important. If you know all this information correctly, then only you can answer the questions, otherwise you cannot. So please don't neglect by thinking that I know all this concept, why should I study? Don't think so. I think probably it will take you the time 1 to 2 hours to revise. If you know, if you have the thorough knowledge on this all topics, all this synopsis, then you can solve the questions. Clear? Because always the base should be strong, then we can build a building. Clear? So what I am going to say is, please concentrate on the synopsis first. If you know the synopsis, then you can solve the questions. Without knowing the synopsis, you cannot. Is it? So therefore, please concentrate on this. So I'll move to the next concept. So please pause the video. I'll move to the next concept. Yes, my dear students, the next concept is algebra of matrices. So what is algebra of matrices? Algebra means what I told. Algebra means the operations, how to add, how to subtract, how to multiply. That all we are discussing, that we can call it as a algebra. We will study that under the algebra of, here it is. We are discussing under the topic matrices, therefore algebra of matrices. So please keep in your mind, my dear students, to add any two matrices or to subtract any two matrices or to multiply any two matrices, there should be some conditions is there. If that condition satisfies, then only we can add, we can subtract, whatever conditions is there, that in particular I am going to discuss. Clear? So the first one I am going to discuss is sum. Sum means addition. If you have the two matrices, A is of the order m cross n and B is of the order m cross n, you can add any two matrices only if the both matrices should be of the same order, then only we can add. So therefore I made here it is the 4 columns, my dear students. I made the 4 columns to understand properly what is the case in the case of addition, subtraction, that all, to discuss that one. And I given here it is, here under the condition I wrote here it is as condition. Condition means what? To add any two matrices, what is the condition is there. And after adding this, the result is what you will get, in which format, what will be the order of the matrix if you add the two matrices. Therefore I wrote it as result, and some properties we are going to discuss. So therefore I made like this 4 columns, and operation first one is sum. So what I told you that we can add any two matrices. Addition is possible only if the order of the both matrices should be same, then only we can add the two matrices. Clear? So therefore I wrote A is of the order m cross n and B is of the order B is also of the order m cross n, then only we can add. After adding these two matrices, then the resulting matrix will be of the same order, that is m cross n only. And how to add the two matrices? The corresponding elements we should add. And the properties is, if you add A plus B, whatever you will get the resultant matrix, the same you will get if you add B plus A. This is what we can call it as commutative. So commutative means what? If you change here it is the order, then the result will be same. A plus B answer is also same, B plus A is also answer is also same. And the second property is A plus B plus C. If you add first A plus B, and to that resultant, after adding A plus B, whatever matrix you will get, to that if you add the matrix C, whatever you will get the answer, the same answer you will get if you add first B plus C, and then to this if you add A, then the answer will be same. There is no any changes. This is all about the sum. Then the next operation is difference. So difference, in the difference also what I told, in the difference also same as I told in the sum. So in this, if you wanted to subtract any two matrices, means they should be of the same order, then only the subtraction is possible. So therefore this is A is of the matrix of the order m cross n, B is the matrix of the order m cross n, then the subtraction is only possible if they are of the same order. And after subtracting this, the resulting matrix will be always in the form of m cross n. Clear? And what is the negative of a matrix A of m cross n? If you have any one matrix A of the order m cross n, then the negative of that matrix is denoted like this, A of minus A of m cross n. And how to obtain this? If you have any matrix A of the order m cross n, to get negative of this one, you should multiply each element of the A matrix with minus 1. Then you will get negative of that matrix. Clear? And next one is scalar multiplication. Scalar multiplication means you should multiply any constant, but the condition is that should be non-zero. Clear? And how to multiply any constant with any matrix of the order m cross n? You just this k may be any value other than 0. If you wanted to multiply to the matrix A, means you should multiply each element of the matrix A with k. then the resultant will get it as k into a. This is what we can call it as a scalar multiplication. And the properties, my dear students, what is the property? To get k gets multiplied with every element. As I told, every element of the A matrix we should multiply with k, then we will get this k. Clear? And next one is, my dear students, matrix multiplication. Very important. In CET, sometimes they'll give you two matrices and they'll ask whether the multiplication is possible or not. So in such cases we should know. So matrix multiplication, please remember, my dear students, matrix multiplication is possible only if n is equals to p. N is equals to p means what? N is equals to p means it is nothing but if you have the matrix A of the order m cross n and another one matrix of the order B, that is another one matrix B of the order P cross Q, then we can multiply these two matrices only if the number of columns in this matrix should be equals to number of rows in this matrix. If these two are equal, then only we can multiply. Please remember, this is very important. Sometimes direct questions they'll ask in your competitive exams. Clear? So in that case you should know the number of columns in this matrix should be equals to number of rows in this matrix, then only we can multiply. So there, and after multiplying this, that is also very important. After multiplying this, the resultant matrix order will be AB will be, that is nothing but after multiplying these two, whatever matrix comes, that matrix all order is m cross q. Clear? So this you should know. Direct result they'll ask sometimes. Clear? So that's why I wrote here this. And then the properties. So what are the properties, my dear students? AB is not equals to B. All times AB is not equals to BA, and A into B plus C. First, if you add B plus C and if you multiply with A, then that value is nothing but you will get the same value if you multiply AB and plus, and if you multiply AB and then if you multiply AC and if you add these two, whatever answer you will get, the same answer you will get if you add first B plus C, and this for this if you multiply with A means the same answer you will get. Clear? And next one is A into BC is equals to AB into C. Again it is just a matter of order. If you first multiply BC matrices and then if you multiply with A, whatever answer you will get, the same answer you will get if you multiply first AB and then to this if you multiply with C. And the fourth property is A into, if A is any matrix of the order m cross n and I is the matrix of the order m cross n. I means what? I is nothing but identity matrix. To the any matrix A, if you multiply with the identity matrix, or to the identity matrix, first to the identity matrix, if you multiply with any matrix A, then the resultant matrix is always the matrix A itself. Clear? It means to the any matrix, if you multiply with the identity matrix, you will get the same matrix A, that is nothing but. Clear? So these are all properties, remember my students, very important properties these are. Clear? So if you sometimes they'll ask the questions from this one. Understood? Say for example, here it is, they'll give you a matrix A is equals to one matrix, they'll give you A is equals to Aij of the order 2 cross 3, and another one matrix they will give you B is equals to Bij of the order 3 cross 6, and then they'll ask, then the resultant matrix AB will be the order of the matrix, then the order of AB is, directly they'll ask like this. So what you will do, my students, as I told, here it is 3 and here it is 3, means multiplication is possible. Then what is the resultant? Here it is, after multiplying this AB, what will be the orders they ask? So what will be the order? So according to our rule, the number of rows in this matrix is 2, the number of columns in this matrix is, here it is 6. So then the resultant matrix order will be 2 cross 6. You will get 2 cross 6 matrix you will get. So like these questions they'll ask. Clear? And next, move to the next concept, that is transpose of a matrix. Very simple. Transpose of a matrix means what? Transpose of a matrix is nothing but if you have the any matrix A, so just we are changing rows into column. Any matrix if they given to you means we should change rows into column. Say for example, take the matrix A is equals to A11, A12, A21, A22, A31, A32. This is a matrix, one matrix we have. If I wanted to write the transpose of this matrix, Transpose of this matrix A is the symbol, we can write it as A transpose like this, or A dash we can write. So what is that? How to get that one transpose of the any given matrix? Just we should change the rows here. It is the row here. It is this row, we will change it as column A11, A12. Second row we will change it as column A21, A22, and third rows A31, A32, A31, A32. Whatever we have the rows, that we will change into the columns. That will gives you transpose of the any given matrix. And the notation for this is A to the power T we should write, or we power A to the power we can write it as capital T, or we can write it as here it is A dash. So these are the two notations we can use for the transpose of a matrix. And then properties, my students. So the first property is A transpose whole transpose. For the any matrix, if you double transpose that one, means that is nothing but A transpose whole transpose is, again you will get the same matrix itself. And next one is K into A transpose is nothing but K is any constant, so K you can take outside and you can write it as K into A transpose. And next, if you have any two matrices, A either addition or subtraction, if you take the transpose of that one, means that value is equals to the A transpose plus or minus B transpose. Clear? And next one is AB whole transpose. This value is equals to B transpose into A transpose. You can call it as reversal law also, you can call. All these properties we discussed, my students. Just I am revising the things. Clear? So please remember all this, and this is very very important as I told, and the remaining part we'll discuss in the next video. I hope you understood up to here. Still, if you have any doubts, you can comment me, I'll reply for that. Please pause the video. Thank you.